There's a lot of excitement right now for the high line rate applications. So carriers, service providers, Web 2.0 service providers in particular, have reached a point in their network where they need a lot more bandwidth. And there's been a realization over the past year that we need higher line rate, not only more wavelengths, but fewer wavelengths with a higher line rate per wavelength. So there's an effort to standardize 40 gigabit and 100 gigabit Ethernet, and this has spurred a lot of interest in high-speed optical techniques and see how these might be relevant to increase the line rate of communication systems. So this is one of the drivers that brought a lot of papers into the all-optical processing committee. So our committee covers two areas. One is the all-optical processing, the other one is the microwave or analog photonics aspect. And so the driver for the all-optical is the higher line rates on fiber. For the microwave photonics, the driver is increased reliance on wireless communications. And there's been a lot of interest, a lot of papers submitted in the radio over fiber portion of our committee as a way to distribute communication signals over a wider area. It could be over a building or a campus. And so this is really what the drivers are to bring papers to our committee. They're somewhat independent areas, and both of them grew significantly. So we've seen a lot of papers submitted where maybe more refined techniques to do optical time division multiplexing that allow to take multiple low-speed feeds, aggregate them into very high-speed signals, and all the techniques related to then extracting out individual time slots out of that very high-speed signals and just essentially processing that information. Wavelength convergence as a technology that's key in the switching nodes to avoid contentions. As you have a lot of capacity coming in the nodes, make sure that two signals carried on the same wavelength do not interfere in trying to access a third wavelength, a third fiber.